Hello guys, today we will discuss inscribed angle formulas and angles formed by the intersector lines with the circles. The first example is about the central angle. If we choose circumcenter and 2 points on the circumference, A and B, angle AOB will be same as the arc measure of AB. We can prove this very easily by using proportion because the whole this arc, this angle will be 360 and also whole circumference will be 360 degrees. We can see that proportion give us that AOB and AB arc measures in degrees will be same. This can be used to compute the uh, AOB sector area formula. This can be written as pi r squared times theta divided by 360. Because we know that pi r squared is the whole circle area, and because of proportion, we will have theta divided by 360. Now we will use this formula for the other lemmas. The first one is about inscribed angle. Angle ABC equals half of AC arc. Now, to prove this, we just need to take the center, O, and as we know that AO equals OB and equals to OC, we will get three isosceles triangles. AOB and AOC will be isosceles triangles. Let's take BO intersection circle point K. If we assume that angle OBA equals to x, angle OAB will be also x. Once again, by using isosceles property. And we can see that the angle AOB will be 180 minus 2x, and from here we can see that angle AOK will be 2 times x. If we use the same argument and assign OBC as y, OCB will be also y, once again isosceles property, and COK angle will be 2 times y. And we can see that ABC will be x plus y, while angle AOC equals 2 times x plus 2 times y. So we can conclude that angle ABC equals half of AOC, which is itself equivalent of AC arc. And so we proved the inscribed angle theorem. Remember this one because this is the most useful angle chasing technique when we have like hard questions. We will also use this one for the remaining three lemmas. Second case is when we have two intersector lines and these lines intersect outside. In this case, angle BAC will be equivalent of BC arc minus DE arc over 2. Let's connect points E and B, and by using inscribed angle theorem, we can see that angle EBD equals half of B, half of B arc, just the ED arc over 2. And by using a similar strategy, we can see that BEC will be alpha over 2. And angle BEA will be 180 minus alpha over 2. And if we write the sum of the angles in AEB triangle, angle BAE will become 180 minus beta over 2 minus 180 minus alpha over 2, which can be converted as alpha minus beta over 2, which is exactly BC minus DE arc over 2. Third example is when we have tangent chord. This one is called tangent chord lemma. In this case, we will show that angle ABC equals half of theta r. There are several proofs for this one. One and the most useful, or most widespread, is if we choose diameter of the circle, call this point K. So center will be here, And this is well known that here we have 90 degrees. Tangent and diameter will make up always 90 degrees. BK arc measure will be 180 because of semicircle property. And KC arc will be theta minus 180 because of the BC minus BK property. Once again, using the fact that KBC is inscribed angle, we can compute this easily. That this will be theta minus 180 divided by 2, which can be written as theta over 2 minus 90. From here, we can see that angle ABC will be angle ABO plus angle KBC or OBC, they're saying, which can be written as 90 plus theta over 2 minus 90 over 2, which can be written as theta over 2. This lemma is the hardest to notice on the hard diagrams because tangent property can be easily forgotten if you don't do a lot of questions like this. And last example is when we have two secant lines and they intersect inside the circle. In this case, theta angle will be alpha plus beta over 2. So just CD arc plus AB arc over 2. Call this intersection point E. If we connect BC and use inscribed angle theorem once again, CBD angle will become alpha over 2 and angle ECB will be beta over 2. So based on this, we can easily find angle BEC, which can be computed as 180 minus alpha over 2 minus beta over 2. And as we know that BEA equals to theta, and this is exterior angle for BEC triangle, this will be alpha over 2 plus beta over 2, which is exactly what we wanted, AB arc plus CD arc over 2. We can see that this one is very similar to the second lemma about the two secant lines which intersects outside the circle. In this case, we have minus mark if the intersection is outside, and if the intersection is inside, we have plus mark. If you want to discuss more questions like this or any different topics, please write in the comments and don't forget to like and subscribe my videos.